Imagine a world cloaked in perpetual darkness, a place where the sun's rays never reach and the concept of daylight is a distant, almost mythical memory. This is the realm of the deep sea, an environment so alien and extreme that it challenges our very understanding of life. The sun's rays are just a distant memory. Here, in the abyssal depths, the darkness is absolute, broken only by the occasional flicker of bioluminescent creatures. These tiny beacons of light are the only illumination in a world otherwise shrouded in eternal night. This is the deep sea, a place of immense pressure and frigid temperatures. The weight of the water above is so great that it would crush most terrestrial creatures instantly. Temperatures hover just above freezing, creating a cold, inhospitable environment. It's hard to believe anything could survive here. The landscape is barren, with scarce signs of life. Yet, against all odds, life not only survives but thrives in this extreme environment. Yet life finds a way. Deep-sea creatures have evolved remarkable adaptations to cope with the harsh conditions. Bioluminescence, for instance, is a common trait, allowing these creatures to communicate, attract mates, and lure prey in the pitch-black darkness. Deep-sea fish, masters of extreme survival, thrive in this unforgiving environment. They have developed unique physiological traits such as pressure-resistant bodies and slow metabolisms to endure the crushing pressure and scarce food supply. The deep sea starts where sunlight fades about 200 meters below the surface. This marks the beginning of the twilight zone, where light gradually diminishes until it disappears completely. From there, it plunges down thousands of meters to the ocean floor. The descent takes us through various layers, each with its own unique characteristics and inhabitants. The deeper we go, the more extreme the conditions become. The pressure here is crushing, hundreds of times greater than at the surface. At these depths, the pressure can exceed 1,000 atmospheres, a force so immense that it would crush a human being instantly. Yet, deep-sea creatures have evolved to withstand this incredible pressure. It's cold too, hovering just above freezing. The temperature in the deep sea remains constant, unaffected by the sun's warmth. This cold environment slows down metabolic rates, allowing creatures to survive on minimal food resources. But this alien world is teeming with life. Despite the darkness, pressure, and cold, the deep sea is home to a diverse array of organisms. From tiny plankton to giant squids, life has adapted to every niche in this extreme environment. Strange and wonderful creatures, the deep-sea fish, have made this extreme environment their home. They exhibit a range of fascinating adaptations, from bioluminescent lures to enormous mouths and expandable stomachs, allowing them to make the most of the scarce food supply. They've evolved incredible adaptations to not only survive but to flourish in this challenging world. These adaptations are a testament to the resilience and ingenuity of life, proving that even in the most extreme conditions, life finds a way to endure and thrive. Deep-sea fish are built differently. They inhabit one of the most extreme environments on Earth, where the pressure is so intense that it would crush most other forms of life. Their bodies are adapted to withstand the immense pressure of the deep. This adaptation is not just a simple change, but a complex series of evolutionary modifications that allow them to thrive where others cannot. Unlike fish near the surface, they often have soft, gelatinous bodies. These bodies are not just for show, they serve a critical function. The gelatinous texture helps them to be more buoyant and flexible, allowing them to move with ease in the high-pressure environment. Think of them as being more fluid, less rigid. This fluidity is essential for their survival, as it prevents their bodies from being crushed by the immense pressure of the deep ocean. Their bones are also different, often smaller and more flexible. These bones are not as dense as those of surface-dwelling fish, which allows them to withstand the crushing pressure without being crushed themselves. This allows them to withstand the crushing pressure without being crushed themselves. The flexibility of their bones and bodies is a key adaptation that enables them to survive in such an extreme environment. Some, like the blobfish, resemble a gelatinous blob, perfectly adapted for the deep. The blobfish's unique appearance is a direct result of its adaptation to the high-pressure environment of the deep sea. But it's not just their physical structure that's special. Deep-sea fish have also developed unique biochemical adaptations that allow them to survive in such an extreme environment. Deep-sea fish have unique proteins and enzymes in their bodies. These proteins and enzymes are specially adapted to function under the extreme pressure and low temperatures of the deep sea. These help them function under extreme pressure. Without these unique biochemical adaptations, the fish's cells and tissues would not be able to function properly under the immense pressure of the deep sea. They prevent the fish's cells and tissues from collapsing under the immense weight of the water. This is a remarkable feat of evolution, as it allows the fish to survive and thrive in an environment that would be deadly to most other forms of life. It's a remarkable feat of evolution. The adaptations of deep-sea fish are a testament to the power of natural selection and the incredible ability of life to adapt to even the most extreme environments. From their soft, gelatinous bodies to their unique proteins and enzymes, every aspect of their biology is perfectly suited to life in the deep sea. These adaptations not only allow them to survive but to thrive in one of the most challenging environments on Earth. In the deep sea, darkness is the norm. The ocean's depths are a world where sunlight is a distant memory, unable to penetrate the thick layers of water above. This perpetual night creates a unique and challenging environment for the creatures that call it home. Sunlight simply can't penetrate the depths. The deeper you go, the less light there is, until you reach a point where it's completely dark. This zone, known as the aphotic zone, is where sunlight is entirely absent. So how do deep-sea fish find their way? Navigating this dark alien world requires special adaptations. These fish have evolved remarkable ways to survive and thrive in an environment where light is a rare commodity. Some have evolved incredibly sensitive eyes, huge and specifically designed to capture any glimmer of light. These eyes can detect the faintest traces of bioluminescence or the occasional flicker of light from above, allowing them to see in near total darkness. Others have taken a different approach, bioluminescence. This fascinating adaptation allows them to produce their own light, turning their bodies into living lanterns. They create their own light. This ability is not just for show, it serves critical functions in their survival. By emitting light, these fish can communicate, hunt, and even defend themselves in the dark abyss. This is done through a chemical reaction within their bodies. The process involves the enzyme luciferase acting on the molecule luciferin, producing light without generating heat, a phenomenon known as cold light. The anglerfish, for example, has a lure dangling from its head that emits a mesmerizing glow. This bioluminescent lure is a perfect example of nature's ingenuity, attracting unsuspecting prey right into the anglerfish's waiting jaws. This light show serves multiple purposes. It can attract prey, entice mates, or even startle predators. In the deep sea, where resources are scarce, these adaptations are vital for survival. Imagine a sudden burst of light in the pitch black. It's a brilliant survival tactic. This flash can confuse predators, giving the bioluminescent fish a chance to escape. It can also signal other fish, creating a complex language of light in the dark ocean depths. Food is scarce in the deep sea. Animals have to be opportunistic, ready to capitalize on any chance for a meal. Some deep-sea fish, like the gulper eel, have evolved huge mouths and expandable stomachs. They can swallow prey much larger than themselves, storing it away for leaner times. It's a feast or famine existence down here, and these fish have adapted accordingly. Others rely on incredible senses. The tripod fish, for instance, uses elongated fins to stand on the seabed, feeling for vibrations. This helps them detect approaching prey in the pitch black. Section 5. Love in the dark. Unique reproductive tactics. Finding a mate in the vastness of the deep sea is no easy feat. Deep-sea fish have evolved some truly remarkable reproductive strategies. Take the anglerfish, for example. The tiny male anglerfish actually fuses himself to the much larger female. He becomes a permanent fixture, providing sperm whenever she needs it. It's a bizarre but effective strategy in a world where encounters are rare. Other species rely on bioluminescent signals or pheromone trails to attract mates. It's a delicate dance of survival, ensuring the continuation of their species in this most challenging of environments. Section 6. The unsung heroes of the deep ecological importance. Deep-sea fish may seem far removed from our world, but they play a vital role in the ocean's ecosystem. They are part of a complex food web, connecting the surface to the depths. Many species feed on marine snow, the constant rain of organic debris from above. This helps recycle nutrients back into the ecosystem. Without deep-sea fish, this delicate balance would be disrupted. They are also an important food source for larger animals, including some sharks and whales. Their health and survival are intricately linked to the well-being of the entire ocean. Section 7. The human shadow. Threats to deep-sea life. Sadly, even in the remote depths of the ocean, human activities are having an impact. Pollution, deep-sea mining, and climate change all pose threats to these fragile ecosystems. Deep-sea fish are particularly vulnerable because they tend to grow slowly and reproduce less frequently. Any disruption to their environment can have long-lasting consequences. It's a sobering reminder that our actions have far-reaching consequences, even in the most remote corners of the planet. Section 8. Protecting the abyss. Conservation is key. Protecting deep-sea fish and their habitats is crucial. We need to expand our knowledge of these ecosystems and implement sustainable practices to minimize our impact. This includes establishing marine protected areas, regulating deep-sea fishing, and reducing pollution. International cooperation is also essential to ensure the long-term health of our oceans. The future of these incredible creatures, and the health of our planet, depends on our commitment to their conservation. Section 9. A testament to life's tenacity, the wonder of deep-sea fish. Deep-sea fish are a testament to life's incredible tenacity. They thrive in an environment that seems impossible to us, constantly adapting and evolving. Their unique adaptations, from bioluminescence to bizarre reproductive strategies, never cease to amaze. They remind us that the natural world is full of wonder, and that even in the darkest depths, life finds a way. It's our responsibility to protect these fascinating creatures and ensure that they continue to inspire awe and wonder for generations to come.